Every single day, company ships AI models into production without knowing where they break. Not if they break, but where they break. A sentiment classifier that fails on sarcasm, a content filter that gets confused by typos, or a chatbot that confidently answers nonsense questions. Now, these aren't hypothetical, they're happening right now in production systems that real people use. The problem isn't that these models are bad, the problem is that nobody tested them properly. Now, our project is an autonomous AI robust auditor. You give it any machine learning API endpoint and then also a one line description about what the model does, and it takes over from there. Now, under the hood, an Amazon Nova 2 Lite, which is running on the Amazon Bedrock, acts as the reasoning engine. It doesn't just run a fixed list of tests, but it thinks. It decides which attack strategies to try and then generates props, queries the models, evaluates the responses, and then adopts strategies based on what it finds. Now, Nova 2 Lite isn't just a wrapper in this project, it's the core. It is responsible for generating the props. It scores the responses. It decides what to prop next. It writes the report. And without Nova's reasoning and tool using capabilities, this project would just be a for loop with HTTP requests. Nova is what makes this project genuinely interesting. Now, for example, if in for the model API URL, we are giving a hugging face model, which is a real-time sentiment classifier that is a Distilbert fine-tuned on SST2, which is one of the most widely used NPL models in production from the Hugging Face. And then we are going to be giving a one-line description about the model in question, which is nothing but it is a binary sentiment classifier that labels text as either positive or negative, which is based on the emotional tone. And we're also giving the model type as a text classifier, but there are also other types of model which are either LLM or a chat model, etc. And the prop depth depends, it's about the how many props we are going for. For example, if it's quick, that means it's a 15 prop thing, which would either last 1 to 2 minutes. Or if it's a standard, that's 30 props and it would last 3 to 5 minutes. Or if it's a deep prop, that is like 60 props, a complete understanding of the model. If wanted, which is an optional in this case, we can also give our hugging face token, or the token of the of from where we have taken our API endpoint of the machine learning model. And then when we click on start audit, we can see that our screen is separated into two different parts. Now, on the left side is nothing but the Nova 2 Lite reasoning in the real time. It's the agent feed. It decides on starting broad, that is hitting all the 8 attack categories, which are the boundary cases, negation, typos, out of distribution inputs, and empty strings. And you can see that the answers or the results that we're getting is nothing but the classification of the model. These are the ones which are classified from the model, and it is also to be known that I have given it to run on 3 iterations. That is, the probing is done 3 times, and there will be dozens of props in each of the iteration to test the model. Now, as you can see just now, we have completed 1 iteration, and just before completing 1 iteration, there have been a few red markings which are wrongly classified examples, and those can belong to either boundary cases or negations or typos. As we just saw, it just completed 3 iterations, and it's also given as a complete audit report. As we can see, it has about 18 findings across 37 props. That is, it took 37 props, it's given the model 37 props, and it found out about 8. And now Now, these findings are categorized into three types. One is high, medium, and then low. And as you can see, these categories are OOD inputs, or the boundary cases, or semantic shift, and these also have a severity breakdown, like how many of them are high and then how many of them are medium, and the overall grade, that is what issues, I mean which level the issues are at. And also an executive summary, which is also given by the Nova 2 model because it scores the review, as we have already previously mentioned. It is said that the audit identifies multiple instances where the binary sentiment classifier incorrectly classified neutral or mixed sentiments and failed to handle out of distribution inputs, that is the OOD inputs, and non English text. And the overall risk level is moderate due to the frequency of misclassifications. Now, that is the summary, and these are the recommendations that the Nova is giving to the model on how to improve the model's ability. It's said to improve model's ability to handle neutral and mixed sentiments by having a more balanced data sheet, or to explore the robustness for out of distribution inputs by incorporating data augmentation, for example. And also the conclusion is also again given by Nova, which is like it shows moderate robustness, but there are notable issues with boundary cases and out of distribution inputs, as mentioned previously. And if we want, we can also download this PDF and then submit this very PDF again. Download this PDF where we can see what we were given with. Like I said, they are divided into high, medium, low, and also critical. Now, before this AdverSense project, finding these failures meant hiring an ML safety engineer, or manually writing test cases and then running them and then interpreting the results, writing a report, which requires deep expertise. And there are tools in the market which are static. They don't reason, they don't adapt, and they don't tell us why something failed or what to do about it. Now, AdverSense is different because the agent itself is the product. Now, Nova to Light here isn't just generating text, it's making decisions about strategy and interpreting the model behavior and then writing the final report. It's genuinely agentic in a way that it creates a real value, and it can be used in future and it can be improved in the future. Thank you.